Mercury may look small and dull, but it's one of the strangest, most extreme and least understood worlds in the solar system. Let's start with the beginnings.
3, 2, 1.
Mercury is the closest planet to the Sun. Because of that, and because of its extremely thin atmosphere, the temperatures range a lot. From 430 degrees Celsius during the day to minus 180 degrees Celsius during the night. It completes one orbit around the Sun in 88 Earth days, and it rotates around itself for 59 Earth days. With a diameter of 4,880 kilometers, Mercury is only slightly larger than Earth's moon. Its gravity is also very interesting because it's sort of weak and strong at the same time. If we talk in absolute terms, its gravity is quite weak. It has only 38% of Earth's gravity, which means its surface gravity is 3.7 meters per second squared compared to Earth's 9.8 meters per second squared. That means that if you weighed 50 kilograms on Earth, on Mercury you would weigh 19 kilograms. But the interesting part is that for such a small size, Mercury actually has a surprisingly strong gravity. If Mercury had the same internal structure and average density as most rocky planets do, then we'd expect an average of 1.5 meters per second squared. That can only tell us that Mercury is far denser than we thought. It's actually almost as dense as Earth is, with a density of 5.43 grams per centimeters cube compared to Earth's density of 5.52 grams per centimeter squared. That can only tell us that Mercury has an extremely large metal core made of mostly iron, which makes 85% of its radius. And for you to understand how weird is this, how weird is for a planet to have such a huge core, it's like you have a 5-year-old kid next to a 20-year-old adult. The kid weighs 45 kilograms, while the adult weighs 58 kilograms. While the kid still weighs less than the adult, it's still much heavier than what a normal kid should weigh at 5 years old, which is around 20 kilograms. Assuming the kid is not obese, you'd assume that perhaps something is about their bones. Perhaps the kid has abnormally large and dense bones. And that's the same with Mercury. Its core, it's abnormally large and dense. So that's why instead of 1.5 meters per second square we'd expect, its actual surface gravity is 3.7 meters per second square, which is more than double. And while not every strange feature of Mercury is caused by that core, many of its most puzzling ones, such as the presence of a magnetic field, planetary shrinkage, and unusual rotation, they all trace back to it. Mercury is tiny, and small planets cool quickly, just like soup. A bowl of soup, aka Earth, will stay warm much longer than a teaspoon of soup, aka Mercury. And coming from this logic, scientists long assumed that Mercury has cooled a long time ago, which means no liquid metal, and therefore no magnetic field. Yet when Mariner 10 flew by in 1970s, it found a trace of a magnetic field. Weak, but definitely there. Which means that part of its core is still molten, which shocked scientists. Something must be keeping it hot enough to stay liquid, and that something, it's the giant size of its core. Mercury's core makes up 85% of its radius. This much metal stores a lot of heat. Mercury has been cooling from what we know 4.5 billion years ago, and it's still not done. And because it's still partly molten, it generates this weak dynamo effect. When Mariner sent back the first close-up pictures of Mercury's surface, scientists noticed something strange. Huge cliffs slicing straight through craters in plains. And these were not impact features, they were clear signs of the crust being compressed. Compression can mean only one thing, which is that the planet is getting smaller. As researchers analyzed the data, the cause became obvious. Mercury has been cooling for billions of years, and as it cools, it contracts. And as it contracts, it gets smaller and smaller. But the outer rocky crust, it's not flexible, it's solid. It cannot stretch to keep up, so it buckles and breaks. Those cliffs, the lobate scarps, are the result. Messenger later mapped the entire planet and found those cliffs everywhere, which confirmed the conclusion that Mercury's radius has shrunk by 7 kilometers, and the whole surface crumpled as the interior pulled inward. Mercury's rotation is unlike any other planet's. It spins around 3 times for every 2 orbits around the Sun, a pattern called a 3-to-2 spin orbit resonance. Let's translate that. 1 Mercury year, which means a full orbit around the Sun, lasts 88 Earth days. 1 Mercury day, which means a full spin around its axis, lasts 59 Earth days. However, because of how these cycles line up, a solar day on Mercury, which means from one sunrise to the next, lasts 176 Earth days. So a single day on Mercury is 2 Mercury years long. To understand better this weird 3-to-2 spin orbit resonance, we'll have to go back in its early history when Mercury's large iron core was still molten inside. Because the planet was so close to the Sun, strong tidal forces acted upon it, which means that it pulled slightly more on the side facing the Sun. That caused a slight deformation in Mercury's shape, as it was still soft inside. And as the planet cooled and the surface solidified, this uneven shape became permanent. Over billions of years, the Sun's gravity kept pulling on this slight asymmetry, gradually slowing the planet's rotation down until it settled into a stable 3-to-2 spin orbit resonance. So while that's not the only reason for its asymmetrical shape, part of it is Mercury's massive molten iron core, which allowed it to be more flexible on the inside during its early history. When the Sun's strong tidal forces pulled on it, the planet could actually deform slightly, like a soft metal being pressed on one side. Because of Mercury's 3-to-2 spin orbit resonance, a day on its surface unfolds in one of the strangest sunrises in the solar system. As the planet moves around the Sun on its stretched elliptical path, its speed changes, moving faster when it's closer to the Sun and slower when it's further away. At the same time, it rotates 3 times for every 2 orbits around the Sun. This delicate balance means that in some regions, the planet's orbital speed overtakes its rotation. For an observer standing on its surface, it would look like the Sun is rising above the horizon, pausing for a moment, drifting backwards, and then rising again, creating this illusion of a double sunrise. It's a surreal consequence of gravity, motion, and geometry. To make this double sunrise and why it happens easier to picture, I want you to imagine you're driving next to your friend side by side around a track. At one point, your friend speeds out, passing you for a moment, before you catch up and take the lead again. From your point of view, it looked like their car is moving forward as they speed up, then backward as you start to accelerate, and then it looks like it's starting to get forward again as your speeds shift and balance out. And that's exactly what happens on Mercury. As the planet speeds up around the sun, it moves faster than its own rotation. So for someone standing on its surface, it would look like the sun is rising, pausing, going backwards, and then up again. A strange slow motion double sunrise. So far we've talked so much about Mercury's massive iron core, but we haven't actually stopped to ask why is it so big in the first place, because that's the main question a scientist might have asked. But unfortunately answers are not given so easily, and that's why we're left with just some theories. The first one says Mercury used to be much larger, maybe twice its size, but a huge impact blasted away most of its outer rocky layers, leaving behind mostly its iron core. So basically the lighter materials got stripped away and what was left was the inner, denser part. The second theory suggests that Mercury might have just simply formed that way. When the solar system was young, the region around the sun was extremely hot, so lighter elements couldn't condense there. The only materials that stayed solid were metals like iron and nickel. Mercury might have formed in this metallic region, while the other planets formed further away where silicates and other lighter elements could survive. The third idea is a combination of both. Mercury might have started metal-rich, but then lost most of its rock through small collisions and solar erosion. Whatever the case, Mercury just ended up like this strange leftover. Mercury isn't special because it's pretty, because it's not. It's really boring and unattractive. But it's special because it breaks the rules. Its massive core, its magnetic field, its unusual rotation and mysterious history, they all expose the limits of our models. Studying it forces us to rethink how planets form and evolve. And that's the point. Even a small planet like Mercury can punch holes there where we think we already understand.